Okay, good. So we are live. Okay, let's wait 1 minute till more people join. Hi guys, thank you for joining. Today we have our final session for FinTech Marathon by Luxoft. My name is Julia and I will be moderating this final session. Let me just briefly remind you our modality how to ask questions. So if you have a question in mind during the presentation, please send this question to the Q&A window at your screens. If you have any other comments or you want to just chat to us or each other, you can use chat for that. Our today's speaker, Alberto, will answer all your questions or the most interesting of them just at the end of the presentation. So please be patient. And actually, no, that's not all from my side. The last thing I would like to remind you that if you are collecting our keywords for a short, for receiving a short gift from Luxoft, this keyword, you'll find this keyword at the very last slide of the presentation. So again, be patient and wait for that. That's actually it from my side. So I'm ready to pass the word to our today's speaker, Alberto. Alberto, please, the floor is yours.
Thank you very much. Hello, everyone, and thank you for joining this presentation. I'm Alberto, and I work for Excel and Luxoft Financial Services as a software engineer and IT consultant. I have extended experience with design, development, and maintenance of applications in different industries. And I have experience with distributed architecture using microservices and big data frameworks. Today, we are going to talk about event-driven microservices. And we'll have an overview of the different, some different microservices architectural styles. And then we'll dive into the event-driven microservices architecture. We'll have a look at what's domain-driven design and why it is important when we implement microservices architecture. And then we'll have a look at the communication structure for event-driven. And we do some comparison between asynchronous versus synchronous microservices. And then we'll go back to event-driven and we'll see what are event stream topologies for microservices. And some more important part of this architecture, like event brokers. And we'll talk about event brokers with a view of Kafka, which is one of the most used message brokers used in the market these days. And then we'll see how to produce and consume events from the stream. So microservices and microservice architectural styles have existed for many years in many different forms and with many different names. Some examples are service-oriented architecture, where they are often created as a number of microservices that communicate synchronously between one another. An example is web services like REST endpoints, for example. Message passing architecture uses consumable events to asynchronously communicate between one another. And an example of this is when you use your microservice to consume messages from ActiveMQ or RabbitMQ, for example. And then we have event-based communication, which is the one we are focusing today, which is not new, but the need for handling big data sets at scale are new requirements that necessitate this type of change from old architectural style. In this type of architecture, systems communicate by issuing and consuming events. These events are not destroyed upon consumption like it happens in a message passing system, but instead they remain available for other consumers to read as they require. In this type of architecture, services communicate with one another by consuming event messages. So basically, when any business event occurs, producers publish them to messages. At the same time, other services consume them through event listeners. So services consume these events from streams. They apply some business logic, and then they may produce some output events, or they can expose the same data via the REST APIs, or some transformed data from the REST API. These type of services can be stateless or stateful. So the events are immutable, and they can be persisted indefinitely and be consumed by any other service as many times as necessary. Any microservice can materialize and manage their data according to their needs and do so at scale. This kind of combination between of events, streams, and microservices forms an interconnected graph of activities across the business organization. So the concept of domain-driven design and bounded context is very important when we build microservices architecture, because each microservice should only be focusing on its subdomain. So the domain encompasses everything that the business must do, like including rules, processes, ideas, and business-specific terminology, and all the related things that are related to the business problem space. Subdomain, so each subdomain on this big domain for the business focus on a subset of responsibility for this organization. For example, the warehouse, the sales, or the engineering subdomain. And each of these subdomain can actually be seen as a domain itself. So the bounded context defines the logical boundaries, including inputs, outputs, processes, and data models relevant to these subdomains. These have a significant impact on how microservices interact with one another, and they should be highly cohesive. So internal operations in the context should be highly related, and communications should occur internally rather than cross-boundary. The connection between different bounded contexts should be loosely coupled, so that if any requirements changes in one context, it doesn't propagate dependent changes in the neighboring context as well. So in the event-based communications, they are not a replacement for a request-response communication, but they are a completely different way of communicating between services. And an event-driven communication structure decouples the production of the messages to the ownership of the data and the access to it. Services no longer coupled with a point-to-point API, but they basically define an event data structure, and this structure is agreed between the consumer and the producers, and then the producers limit their own responsibility to producing well-defined data in the event streams. So anything can be communicated with an event, from simple occurrences to complex stateful records, and all the events are the actual data, the single source of truth for the application. So this type of communication structure is incapable of providing any query or data lookup functionality. The business and application logic must be encapsulated within the producer and the consumer of the events. And the data access and the modeling requirements are completely shifted down to the consumers. And each consumer obtain their own copy of events. So they consume all of the events. And if they need to do some filtering, this filtering is not done when you consume the events, only consuming the events you are interested in, but you need to consume all of the events, and then the consumer itself applies some transformation after receiving the data. And also the consumer is responsible for mixing data from multiple event streams and apply some special functionality in query or other business logic to the data. So the producers and consumers are now only limited in their responsibility to solving their needs of the bounded context. So usually not all the data is required to be shared with other services or projects. And not all of it needs to be published to a set of event streams. But when the data is needed from other services, it must be published to the common set of event streams, and the production and ownership of data becomes fully decoupled. So new services can simply acquire the data from the event streams and apply the models and states and perform any business logic that they need to apply without having to depend on point-to-point connection or APIs from any other services. This way of communicating events unlocks potential for the organization to use this vast amount of data more effectively in any project in the business, because they don't need to be coupled to many services. They just can get this data from the event streams that are public inside the organization. So as we have discussed before, the event-driven microservices enables the business logic transformation and the operation necessary to meet the requirements for the bounded context. These requirements are fulfilled by applying some transformations on the data based on the business logic for the subdomain they are operating. And then each microservices can then emit their own necessary events for other downstream subscribers. There are a few advantages of using this type of microservices architecture. Microservices are more granular because they map to a bounded context, and they are easily rewritable in case the business requirements change for that context, for that domain. They are scalable, so individual microservices can now be scaled up or down when needed based on the throughput on the stream, and they don't depend on any other services for doing this. They are loosely coupled, so the only coupling that applies to these microservices is on the domain data and not on the specific APIs. And you can create some data schema to improve the management of data changes that needs to be shared between microservices. They are highly testable because they have less dependencies compared to monoliths, and make it easier to mock out test endpoints. On the other side, we have synchronous microservices implemented for point-to-point architecture. And this type of microservices is used on service-oriented architecture. So synchronous microservices tend to be fulfilled by using request response approach, where the services communicate directly through APIs, fulfilling the business requirements by calling these REST APIs and retrieving some data from other services. Neither the point-to-point request response microservices or the asynchronous event-driven microservices are better than one than the other. Some tasks are better suited for one, and some others are better suited for the other. Certain access patterns like authenticating a user or registering or integrating with an external API. These are some patterns that are better suited for a synchronous mechanism where the communication can be language agnostic by using HTTP connections. Event-driven microservices, though, offer some more flexibility that is absent in these traditional request-response microservices. Some of the impediments, or maybe better call them characteristics of this kind of architecture, are that the microservices are point-to-point coupling, because there are services that rely on some other services to help them perform their business task. The scaling is dependent on the ability of dependent services to be able to scale up as well. This is very important because if you want to scale up one service to handle a higher throughput, but the dependent service cannot scale up at the same time, you may kill that service by sending a larger amount of requests. So this is very important to scale up both the services at the same time. Another important point is they need to handle services failure, because when the dependent service is down, they need to make a decision on how to handle the exceptions, handle outages and retries and fails and something like that. This is these days achieved by using circuit breakers, for example, where if the dependent service is down and at any point in time, the circuit breaker can be open, the circuit can be open, and the service can return a default value or an exception in case the service is down, the dependent service is down. And then after some time, some predefined time, when the other service could be brought up again, the circuit breaker is closed again, and the call to the other service is restored. Another important point is API versioning and dependency management, because when you update a REST API and you create you make some changes to your service, you need to make sure that the clients to your service can also update at the same time. And this doesn't happen all of the time. And indeed, sometimes you may find yourself having to have at the same time 2 different versions of the same API, so that clients can decide if they want to switch to the new service or if they want to keep using the old service. So in event-driven microservices, we have the term of microservice topology, which is used to mean the processing logic for any individual service. This defines the operations that needs to be performed in incoming events, including some transformation, storage, or emission of new events. In the picture on this slide, we can see a microservice topology where this microservice is consuming from event A and event B. And from the event B, it creates a materialized state store, and we'll see later what does this mean. And from the event B, it's creating some transformation, some filtering, and then joining with the state store. And at the end of this topology, it provides some output stream for other microservices to consume. So there are 2 types of topologies in event streams. And there are stateless, where some of the applications don't require the state, don't require any state when they process a message. So the processing of any message is independent from the processing of other messages. Some of these transformations, the stateless transformations available are the filter, map value, transform, and many others. Then we have stateful transformations, stateful topologies, where some applications require state in order to work correctly. And this application is stateful whenever it needs to join, aggregate, or window some input data by different messages. So this type of microservices need to maintain a state store, and each microservice, each instance of a microservice maintains its own state store based on the partition of the data it is working on. A simple example of this type of stateful transformation is the word count application, where to maintain the counts of the words in multiple messages, you have to keep state store containing the count of the words coming from the previous messages, and then to be reused for adding up the new values from the message that we are processing at this time. And then we have a business topology, which refers to a set of microservices or streams that fulfill complex business functions. So this set of microservices implement the business bounded context and the event streams to provide a data communication mechanism for sharing this cross-context domain data. In this picture, we see a set of 3 microservices. For example, we have a microservice 1, which is reading from, consuming from event stream A, applying some transformation based on its topology, and then producing an event stream B. This event stream B is consumed from both microservice 2 and 3. Microservice 2 is probably doing some internal transformation and then storing this data into some data store, and then exposing this data through a REST API. Microservice 3 is doing some other transformations, and then is publishing the data in an event stream C. So an event can be anything that happened within the scope of the business communication structure. For example, it could be reading an invoice, booking a meeting room, hiring a new employee, or anything else that could happen in the real world. Events represent indeed something that happened in the real world, but they don't include any expectation on future action. They are the single source of truth, and they describe something that happened in the real world indeed. But basically, the event doesn't give you any command to apply on the data. They just represent something that happened, and then each consumer to these events applies the command, the business logic, the transformations that are important for the bounded context they are working on. So events are typically represented using a key value format. The value is used to store the complete details of the event. And the key is used for different purposes, like event identification, routing to a predefined partition, aggregation operation with events with the same key. And it's important to note that the key is not a required field for all the event types. So there are 3 types of events. There is unkeyed events, and an example of this could be an event that indicates a customer interacted with a product. For example, a user opening a book entity in a digital book platform. And this is a singular statement of fact. And as for the name, this type of event doesn't have a key involved. Entity events So this represents an entity which is a unique thing, and the key for this thing, this entity, have to be unique. This entity event describes the properties and the state of this entity at any given point in time. So this entity, this type of entity event is most commonly an object in the business context. For a book publisher, for example, is a book entity, and the key for the book is the ISBN for the book. The value field contains all the necessary information related to this unique entity. This type of event, the entity event, is very important for from this type of microservices architecture because they provide a continual history of the state of the entity. And this type of event is the one that can be used in the materialized state that we've seen in the previous slide. So when we materialize the state for this type of event, only the latest entity event is needed to determine the current state for the entity. And then we have a key event, and this type of event contains a key, but the key doesn't represent the entity. The key is used for partitioning the stream to guarantee data locality in a single partition for the event stream. An example of this could be a stream of events where, for example, a user has interacted with a book, and the key is the ISBN of this book. So you basically, when you produce a new event for this type of event, you show which books this user interacted, and you do it in a sorted way. So each event, one of the other, is ends up in the stream in an ordered way, in a sorted way. So the event broker, as I said at the beginning, we're taking as example Kafka. Is a system which receives events, stores them in some ordered event stream, and provides these events for consumption by other processes. Multiple distributed event broker can work together in a cluster, and they provide a platform for production and consumption of event streams. So the events are typically published to different streams. They are called topics. And these streams are based on their underlying structure of and logical meaning for the events. Events are appended at the end of the log, and they are given an auto-incremented index ID. The consumers of these events use a reference to the index ID to access the data, and they keep this reference to know from which reference ID they need to continue reading next event on the stream. The essential features provided by message brokers, event brokers, are scalability. So you can add multiple broker instances and add multiple broker instances to the cluster to increase the production and consumption of event and the throughput of events. Durability, so event data is replicated between the brokers so that if any of the brokers fail at any point in time, the events are preserved in other brokers by replication. High availability, you can connect to any broker in the cluster. So the clients can connect to any broker in the clients, the producer and consumers, because if any of the brokers fails, the connection is kept online because they can connect to the other brokers. These brokers are highly performant, and they are able to handle hundreds of thousands of reads or writes per second. There are also some requirements for that an event broker needs to provide for storing events. So brokers must allow partitioning, so the creation of multiple partitions in a topic. Ordering of data is very important in streams. When you have partitions, multiple partitions on your topic, each partition is ordered and the events are served in the same order as they were published in the stream, in the partition. Events are immutable, so the event broker must ensure immutability of the events, so they cannot be modified once published. If you need to make any changes to an event, you need to send another event with the changes that you need to apply to the previous one. It needs to provide indexing, which means that each event is assigned an index when this is written to the stream, and this is used by the consumers to manage the data consumption. Infinite retention, which means that, as I said at the beginning, event streams must be able to retain events for an infinite period of time. You can obviously configure this type of configuration parameter, because you may want to keep the event only for 7 days, or for example, for 1 month, or maybe for 1 year. And then after this amount of time, the event is no more needed for your type of application. Event brokers need to also provide replayability of events. So the event streams must be replayable, so that any consumers at any point in time, they can reread the data from the beginning. So for example, if at the end of the year, the company wants to get some insight of what happened throughout the year on their sales, for example, they can replay the events and then create some graph on what happened throughout the year and make some assumption from this graph for the new years, for example. So a producer application is an application that can act as a source of data in an event-driven architecture. So producers send events to the event brokers, and these are stored into the topics. Topics, as we said before, can be split into partitions, and this allows better performance and scalability. And the messages on each partition are guaranteed to be stored in order in the sequence they came in. And the example here, we see a topic with 3 partitions. And another important thing about partition is that the partitions of a topic, they don't need to have the same amount of events at any point in time, because this depends on the business logic that you apply on your application. So you may want to send events for an ID that starts with A to H to partition 1, and then the other events from I to Z to partition 2. And then they end up having different sizes based on the type of events that you receive. So consumers are the subscribers responsible for reading records from 1 or more topics and 1 or more partitions of a topic. Each consumer is responsible for updating its own pointer to the previous read index within the event stream. So this index, which we have talked about before as well, is known as the offset, and this is the measurement of the current event from the beginning of the event stream. This allows multiple consumers to consume and track their progress independently of one another. In this picture, we see that we have 2 partitions and 2 consumer groups, which are consuming the data from different points in the partitions. The consumer group is another important notion in Kafka and in event-driven application architectures, because it allows for multiple consumers to be viewed as the same logical entity, and can be leveraged for horizontal scaling of the message consumption. When a new consumer joins the consumer group, it causes a redistribution of the partitions assignment to the consumers in the group. So the new consumer consumes events only from the partitions assigned, and the other consumers in the consumer group get a subset of the partitions based on what the new consumer is being assigned. So as a conclusion to this presentation, we can say that event-driven microservices architecture are very powerful, flexible, and provide a well-defined approach to solve business problems. The communication of the data remains decoupled from the business logic that transforms and utilizes the data, offloading these kind of requirements from for the individual bounded context. And this separation of concerns allows the event broker to remain agnostic from the business logic requirements and only focusing on storing and preserving and distributing the events to the consumers. So the microservices implementation can be built to align with this bounded context, and the resultant services and the workflow align to the business problems and the business requirements. The data communication layer facilitates these alignments, ensuring that the microservices implementation are flexible enough to adapt to changes to the business domain. The event broker is an essential part of this type of architecture because it provides the essential communication structure between the services and stores the data that allows consumers to read this type of events. Events are obviously very important in this type of loosely coupled application architecture because they provide replication from one application to another. This event-driven microservices is a natural evolution of computing for handling large and diverse data sets. The compositional structure of these event streams is very flexible and allows individual business units to focus only on whatever is necessary to accomplish their business goals. So, the communication layer extends the power for an organization's data to any services or team that requires it, because it eliminates access boundaries and reduces the complexity related to the production and distribution of data between different applications. So thank you everyone for joining this presentation. And if you have any questions, please send them to the Q&A box.
Thank you, Alberto. And we already have one question there. Well, I can read it if you want. Can you speak to personal preferences in terms of the framework for microservices and messaging? And how these preferences developed over time, considering the external requirements and your experience?
So, so there are different frameworks, obviously, on the market, and the usual ones are the ones that I've always used when implementing microservices. For example, Spring is one of the frameworks that is very widely used in microservices architecture, like Spring Boot, Spring Boot obviously provides different type of libraries for point-to-point architecture and for messaging as well. I personally prefer when I use messaging and Kafka to use the Apache Kafka API and the Confluent API instead of using the wrappers that Spring has implemented around the Kafka APIs. But in terms of point-to-point architecture, I find very useful the libraries that Spring provides for the REST APIs and for security, for example, and also for data storage as well.
Okay. I can't see any more questions in the queue. Oh, no, I can see one. One more. Have you tried using AI-driven triggers to generate events? Any clue about AI tools for that?
No, no, yeah, artificial intelligence. No, I've never worked in an artificial intelligence sector, so I cannot really help on this.
One more. Would it be correct in the particular case of Kafka to consider an event blocker as a server?
Yes, even brokers are servers in the case of Kafka. So yeah, you basically install Kafka brokers into multiple servers on your microservices cluster. Sometimes you don't choose servers, but you use, for example, Kubernetes to install the Kafka brokers and then use this Kubernetes cluster for your microservices architecture.
Good. Let's give guys like a couple of minutes to send more questions. If maybe somebody is typing now. Yes. Can we archive event-driven architecture without Kafka?
Yes, there are other event brokers frameworks on the market. I've always used Kafka for this type of events that are consumable multiple times from the event streams. But for example, even cloud providers nowadays provide some type of event streaming services. And an example is also serverless. Basically, serverless works with events. When an event occurs, then a Lambda, for example, in AWS is called to make some transformation based on the event that they have consumed. So yeah, for example, in AWS, you can create Lambda functions that monitor, for example, S3. And when a new object is saved in the S3 storage, you can define a Lambda function to be triggered based on this type of object and provide some business logic to analyze the object that has been saved into S3.
Okay, good. I see one question in the chat regarding where to send the keywords that should turn into a sentence. Guys, you have our email address, which is employerbranding.laxov.com. In every email notification that you received for the marathon. So you'll easily find this email there, and if you collected all 4 words, then you can send them to our email box. One more question to you, Alberto.
Yeah.
Is there a tip or technique in eliminating number for events? If the number goes too high, people stop paying attention.
So, so for example, in Kafka, you can configure how long you want the events to be kept in the event stream. This configuration basically defines the time that you want to keep these events. I think, as I mentioned this during the presentation as well, if you want an event to be in the stream for 1 week, you can set the retention period to 1 week or 1 month or 1 year or 2 years, whatever you need for your business to work. Because in some business, for example, it's important to have events kept for 1 year or more, so that at the end of each year, you can see what's the progress during the years, for example, during each year in the sales department, how many items have been sold, for example, during 1 year, and what's the difference from the just finished year to the previous year as well.
Thank you. I see question in the chat, how to access last recession if I missed them. Guys, probably tomorrow. Well, I'll do my best to do it tomorrow, but more likely at the beginning of the next week, you'll receive an email with links to recordings of all 4 sessions. We'll publish them on YouTube and we'll send them to you, so you'll be able to watch them and well, review one more time. One more question to you, Alberto. Is replayable functionality automatic? I hope I pronounced it right.
Yeah, replayable functionality, yes.
Yeah.
So each consumer of this event, you need to assign a consumer group. So for example, I don't know, a consumer group can be a name like consumer group 1. This is the most stupid example. And in this group, once you have started consuming events, your offset increases for each event. If you want to replay the events, the consumers have some method that allow you to point your offset to the beginning of the stream or to a defined timestamp. So you can say, okay, I want to replay the stream from this timestamp in the past. Another way of doing that, if you want to use a different consumer and apply different type of transformation, you can create a new consumer with a different consumer group. And this new consumer group automatically starts from the beginning of the event stream and replays all the events from the beginning, apply the different transformation logic that you need.
Okay, great. I can't see any more questions in the chat. No questions in the Q&A as well. So guys, I believe that that's all for now. Thanks everybody for joining. I hope you enjoyed this session and 3 previous sessions. Again, we'll publish at the beginning of next week, we'll publish all recordings in our YouTube channel, which is Luxoft Corporate. You can find it on the YouTube easily, and we'll send to you all links and a short survey to find out what could be done better from our side. Please don't forget to send sentences to our employer branding email. You can find it in your email notifications about sessions. Please send it next week to us. Not just not info news@laxov.com, not this email. I see one person mentioned it in the chat. This is the wrong one. Just at the bottom of email notifications, you see employer branding email. Please send it there. So that's all from my side. I wish you very good rest of the day, and hope you'll enjoy the coming vacation, the coming weekend, not vacations, I'm sorry. But maybe for somebody it will be vacation, so enjoy the day. And Alberto, thank you so much for the great presentation.
Thank you everyone for joining.
Thank you. Bye-bye.
Bye-bye.